Yep, okay. Okay. Welcome, everyone. Thanks for joining us this morning. I think it's really good that everyone's all together here today as well in an in-person event, and it's great to get so many data technologies under one roof. So before we get started, a few introductions. So I'm Sean, I'm the CTO at OSO. I co-founded the company in 2017 with a focus on helping companies adopt emerging technologies, pretty much like data mesh as it is today. We're a Confluent preferred partner, and in EMEA, we work on some of the largest scale projects, working with some of the leading companies in the data space, delivering data solutions at scale. Neil, over to you.
Hey everyone, I am Neil Avery, previously Confluent, and I do a lot of consulting in the fast data space. So this is Apache Kafka, MSK, Confluent Cloud, and that's why we're talking about data mesh in the fast data theater. So in case anyone's curious.
Cool, thanks Neil. Okay, so actually when we submitted this talk, we have something to confess. When we actually submitted this talk, we actually learned a lot about the tooling in the space, and things have moved on, and essentially we've had a few iterations of where we are now. So we started to focus on, we want to focus on giving ubiquitous access to data throughout the whole organization in a repeatable, scalable, and secure manner. We've only got 30 minutes, so we're trying to distill this down essentially to three main parts. So the first part is going through our research, what we conducted, the available tooling, and how we tried to remove all of the noise and marketing material from what's out there at the moment, keeping things as simple as possible. Secondly, Neil's going to walk through an understanding of basically using a specification-driven approach to building data mesh and the full life cycle, and using that full life cycle to drive the data product. Finally, I just want to give a quick a couple of demos and screenshots of some of the stuff that some of the tooling we've put together, and where we want to head in the next weeks and months ahead. Okay, so let's get started. So as you can see, that's pretty scary, right? So that's the Gartner hype cycle there. So yesterday, you probably left here with more questions than answers. And this is a true reflection of the space right now. You probably, you don't know what the marketing material is. You're looking at vendor-specific locking products, and there's a lot of noise in the space, essentially. So we're trying to distill that down, right? So we're trying to remove the noise, and we can see clear there that data mesh is essentially, it's an emerging trend, right? So it's not so evolved compared to the technologies that you can see on the screen. As I'm sure you're aware, that there's a lot of vendors moving into the space, and we need to challenge the fact that these vendors are pushing platforms. So we need to think of things from a perspective of building blocks and not platforms. So not one solution is going to just deliver you data mesh, and always be wary of that. So we need to look at the standards and how we can repeat them across the different products that we can tie together in order to build that data mesh. So what we can agree on, if we distill that down further, is the fact that the four main pillars, right? So everyone knows what the four main pillars are. They're designed to basically break up the central engineering data hub, right? So at the moment, historically, we've had these large expert-driven data teams which have to make sense of domain data with no visibility over what the questions they're trying to ask or answer. So we need to move away from these siloed, expert-driven data lakes to something that's more relevant for each domain. I'm sure we all know that. So if we quickly go through the functionality that each pillar has to deliver, then we can maybe map on the tools that we need to deliver that functionality inside the business. So domain-driven is basically decomposition of the data teams. So we need to break up those central lakes and those experts, so that people that are familiar with basic developer tooling can start using data in their day-to-day developer workflow. So data as a product, we need to give ownership to those teams to ensure that there's accountability, and there's also an incentive structure there to keep the data accurate, right? The self-service aspect of it, this is really lacking at the moment, in the sense that there's not that much automation around the tooling, and I think the tooling needs to catch up, which we'll go through a bit later. But there's vastly different levels of experience in the different teams across your business. Some will be proficient at using some technologies, but others will be much further down that learning curve. So we need to abstract that away and try to get to a unified way of consuming the tooling throughout the business. And finally, the governance, right? So I say finally, but it actually should be at the point and heart of what we're trying to do. So it shouldn't be something we scale on, tag on at the end. These standards need to be interoperable and throughout the organization, essentially, not just tagged on at the end. So when I started hearing about data mesh a couple of years ago, I started to kind of dig more around the 4 pillars. And I don't think they're actually that new. And some of the things that we've been doing, that they fit into technology patterns of the event-driven architecture. So Kafka, etc. So what's evident for me is that it's an evolution of that architecture that we've been building for like several years. And I'm sure you're aware that many organizations run Kafka at large scale as an event sourcing system throughout their business. So with the rise of Kafka came the need for schemas, right? So I'm not sure of all of your knowledge around Kafka, but essentially, if you want to decouple something producing events, like producers, to anyone who wants to consume those events, then we need a standard definition between that object that's being stored in Kafka. So that gave rise to the schema registry. So the schema registry was essentially created as part of a binding to build or push objects to topics that could then be read by consumers. So that level of abstraction could then scale throughout the business. The producer did no longer have to worry about who was consuming their events in a serialized and deserialized way. So what does that look like in a large organization? So this is the Confluent maturity curve. So some of you might have seen this. The concept is a central nervous system. So on the right, that's where you want to get to, right? So it's a well-trodden path in the enterprise. And for those of you not familiar with this concept, it's basically modeling your business through events. So something like Kafka not only acts as the transport mechanism, but it also acts as the storage mechanism as well. So that will come into play in the tooling we go through in a bit. So if you get to level 5 on the Confluent maturity curve, or the event-driven central nervous system, then you're basically 90% the way there to delivering a data mesh inside your organization. So what we've tried to do in the tooling and the subsequent examples is we tried to use our experience from building these event-driven systems at large-scale organizations to apply them to data mesh essentially. So I think it's just quite important. Like I've mentioned data mesh quite a bit there, and so you'll probably hear this a lot today. But the things that it shouldn't be is, it's not integrated into large vendors, right? It's not one big platform, so that's a really big no-no. Things should be simple. We need to free and leverage open source tooling, and this tooling should allow teams to map their domains in a language specific to their particular skill set. We need to move away from platforms into protocols, from like one single team of experts into developer-friendly tooling. Lower the barriers essentially to the world of data engineering. Allow governance as well as part of the heart of the product, and not something that should be tagged on at a later stage. So that's the theory. What's the solution? So Neil, over to you.
Thanks, Sean. So I'm going to talk about spec mesh, but this is kind of like think of it like Agile for building data mesh. It's a methodology. But like anything, when we first start doing Agile, all the tooling doesn't exist. But as Sean was saying, we build large-scale event-driven systems, primarily on Apache Kafka. So some of my customers at the moment are on MSK. Some of them on Apache Kafka, migrating to either Confluent Cloud or MSK. So we see some really large-scale event-driven architectures at the central nervous system scale, and obviously a lot smaller than that. And every time I go into a new customer, I see the same problems again and again. So the first one is like, how do I connect my organization? How do I model everything as events? And then you kind of think back to when cloud first came about. What did they say you needed with cloud? You need storage, you need a network, and you need compute. And the way that we're building applications these days, like fast data, real-time applications for the connected organization, the two things you really need are events and storage. So you need an eventing platform like Kafka or something like that, and you need storage. Not everything fits in an event, and you're going to have lots of data throughout your organization. So we're not saying you should displace that. We're saying data platforms exist. Any large organization's not going to go and move to some new vendor that says, hey, I have a data mesh. So events and storage already exist. Then the other problem that you have is you go into an organization and you look at their topics. And you've got topics with spelling mistakes in the names. They've got auto-create turned on in production. And every broker ecosystem is like a graveyard of stuff where people have tinkered around. And then they go and create topics in code. Or they're using JuliOps or Kafka DevOps. So they've got different ways of doing all of these things. Nothing's standardized. Nothing's unified. And then there's no hierarchy. So who owns what topic? So the first thing we do when we go and talk to these customers is like, let's figure out how we can organize you using a domain-driven approach. So we start with the domain model. We organize the topics hierarchically, which I'm going to talk about. But we go through consumer IDs, app IDs, everything. So when you have a shared Kafka ecosystem, you can understand who owns what. And then you can build your ACLs and everything else around that. So this is something that we do again and again and again. The other thing is everyone has data quality department. Everyone has a data catalog. All of these things should exist, they will exist, and they should not be displaced. They need to be embraced. And then we see, everyone's data is evolving over time. Their architectures evolve, their data models change, so registries are everywhere. But the major problem is this inconsistent approach for provisioning data infrastructure. Some of it's in code, some of it's done. Sometimes people don't know how it's done, which means we end up saying, let's use a specification-driven approach. So that kind of is what led us to where we are. Is anyone here familiar with the async API spec? It's not new. What about Swagger? Open API. Right, so it's like 10%, and the 90% of you that aren't familiar, it's probably a good idea to look at the Open API and the async API, which is like the asynchronous version of that. So a specification-driven approach allows us to formalize the data model, capture it, share it, a bit like a schema for your data model. In fact, the schema for your data model can be embedded within the spec. So the whole thing goes hand in hand, and what it embraces is what we call in the Kafka world is data as an API. We just happen to be capturing that spec or using that spec as the API. The other kind of pet peeve of mine is when you go and get some big data products from some of the vendors around here, the last thing that they will give you is developer tooling. They say, hey, use our SaaS, but they won't tell you how you can build, test, and include it in your data pipelines, or even mock it out. But a lot of the time that doesn't exist. So we're developer-led. You should be able to unit and integration test everything. You should incorporate it into your pipelines. You should be able to automate Terraform through all of these things. And then you should be able to use third-party data catalogs and everything else that you already have in your organization. So these are the things that we tackle with Spec Mesh. It's not new. It's just kind of figuring out what we can do in a repeatable, logical manner that starts out simple and everyone can use. So the first thing that's going to happen is if you said, well, we want to use this approach, you're going to have a GitHub template. You create your repo from that template, and that template's going to be seeded with a build. So it's going to be Gradle. And in that, you're going to have a spec. And the spec's going to be empty. And the first thing you need to do is like, what's my domain model? Where do I sit in the organization? Or where does my application sit within my department, within the organization? So what we've done here, you probably can't see it up the back, is we've basically got Olympia in the middle. That's us in the little purple building. We're in Hammersmith, and we've got accommodation. We've got all these things. So the first thing you do then was like, what is the hierarchy? How do I organize this for scale? And if you look at it, it kind of makes sense. But if we organize this as a hierarchy, we come up with this really simple pattern. We've got London, we've got the borough, we've got the venue. The venue's going to have events. We've got different types of things in the borough. We've got retail, transport, accommodation, services. Pretty straightforward, right? And if we look at the first one here, we're going to build a data model for Big Data London. So we've got Hammersmith, Olympia, Big Data London. We've got public events, which means when we think about how this data is going to be shared, if we mark it as public, then you can self-serve that data. It's freely accessible to you, which means we put an ACL in place that, well, we don't put any ACLs in place to prevent access. But you coming in here, having your QR code scanned, you will go into the attendee topic. Then we've got some other ones. We've got transport for the tube, and then we've got transport for the airport. So if you came here today through Heathrow or on the tube, you would appear in those topics owned by those data products. And then we've got vendors, if you bought a coffee, or if you've gone and got your QR code scanned as a visitor, or you purchased something from one of the shops here. So that's kind of like the basic model that we're looking at. And unfortunately, I think no one can probably see this slide because of the background, but this is the spec. If you want to have a closer look at this, come and see us after, and or have a look at the GitHub page because the same spec's there. But in the purple lines that actually should be red, the top part of the spec has an ID, and the ID is where we catch the domain. So everything within this specification belongs within that domain. So when we go and provision the topics, we use that as the root. The next part down, we've got channels, and within channels, we've got the public attendee. So by combining the two with spec mesh, we will go and use Terraform to actually go and provision those topics based upon the specification. So that happens as part of the build, part of the unit test. Furthermore, when you look further below that, you can see we've got humans arriving, that's you people, and we've got some tags. And those tags are going to be what gets published into the data catalog along with the taggable attributes, so it becomes searchable and you can find stuff. But that's just a snippet of how a spec gets provisioned and pushed into your data infrastructure. So we're not changing data infrastructure. All we're doing is taking a spec and we're integrating it with your data infrastructure in a way that doesn't displace anything and cost you more. So there's three parts to this. We've got capture, provision, and serve. So the first part of the capture is we create the repo, we get the spec, we apply the domain model, which I just talked about, which was Big Data London. We specify our data event streams or our topics and our storage within the channels. We apply tags. We can permission the topics as public, which means anyone can access it. Protected, which means you can't self-serve the governance to it. It has to undergo some kind of governance callback for authorization. And private, which means only you in your data team that own that data product can mess with that data. So if you've got streaming applications, you've got anything else within there that you need to drain or control, that's within your remit. And of course, all of these have schemas behind them. And then the other thing is, once you've got this, you'll go and write a unit test to go and make sure it all works. And the unit test will spin up a localized Kafka container. And within that, it will use Terraform to provision the topics from your spec. Right? So pretty simple, right? As your spec gets pushed, or as your application gets pushed through the build pipeline, it's going to start provisioning real infrastructure, your real brokers. So the pipeline-driven part of this pushes everything to the data catalog, publishes the schemas onto the schema registry, and at that point, we're ready to serve. And when we're ready to serve, that means this product will be live. Your microservices, your stream processors, or whatever they are going to be running through EKS. And others can go and find your version of that data product through the data catalog, search using tags, and the whole thing starts to become discoverable. Again, we've got the resources, which are public, private, and protected, which is a really simple thing that I've used all over the place. So then when it's running, you've got these green circles, which are your data product. You've got the data flowing out. You've got the circles in the middle, which are your private topics. And you've got your specification and the tags for that specification being pushed to your data catalog. All without buying any new vendor hardware, software, I should say. So that leads us onto the developer tooling.
Thanks, Neil. Okay, so remember, we want to do this at scale, right? So the expectation is that everyone in the organization should be able to pick up the tooling and run with it, essentially. So, why should we consider this approach? Using this developer-first tooling. We don't want to deploy platforms, and the specification is the key here, right? It's repeatable and it can be shared throughout the organization. Secondly, focusing on this developer tooling gives us two advantages. First, we abstract away the complexities from the data engineering aspect of deploying and building these tools. So the barrier for those average developers is lowered so that they can then leverage the developer workflow that they're more comfortable with. Understanding the operational data might then give them an advantage to their day-to-day applications to fix issues before they've even arised. Finally, using a specification-driven approach, the lifecycle provides a standard way to provisioning, like Neil said, to test and deploy your domain model. So this provides flexibility in the perspective of structure for public, private, and protected parts of the data model. So the mission of Spec Mesh is to give a consistent workflow to provisioning data products in any domain, paving the way for ubiquitous data across the organization. So how technically are we going to deliver this? I'll walk you through quickly what we've built so far. So on the left, we've got the specification, as Neil was talking about, which we've basically updated. It can be updated on the release of the cadence of the data domain teams. So it's their responsibility to basically keep the specification up to date. The specification is a target state. It's not a procedural. It's not procedural in nature. So this is where we will leverage Terraform. So for example, if you have a data product with a number of public topics, and then you want to amend one of those public topics to a private channel, it's the Terraform and the process is not going to duplicate the data. It's just going to add permissioning on top of that as the state is maintained within Terraform. So that's the crucial thing. You're not duplicating data, and that life cycle is managed by the specification and the tooling. As Neil also mentioned, the way that we're using Terraform is we're using the kind of relatively new CDK. So this allows us to programmatically generate configurations in JSON, which Terraform understands. So instead of defining it as your HCL, you can actually define it in the programming language of choice. So essentially, not YAML, but in Java, in Python, in Node, and this will actually get transformed into JSON, which Terraform can understand. So that's the really crucial bit here, right? So we're parsing the spec, and then we're using our native language that we're comfortable in, Python, Go, Java, or Node.js, to transform that into Terraform understandable code, and then we're using Terraform to manage the state of the clusters. So finally, we can create and update and deploy resources, with a standard Terraform lifecycle. And this JSON can be then, obviously, a specification on JSON can be version controlled, and we can move ahead in a pipeline. So initially, we're just doing this in Java, but as I said, there's lots of other languages. So kind of just to walk through, to walk through an example here. So we basically got, on the left, we've got the specification output. So that's the JSON that has been generated from the CDK of Terraform. On the right, we have the provisioning summary. So here, no resources were changed. So we have the output. We can then assert against that. And below that, we have basically test containers infrastructure. So everything that's fired up locally will be the same if you have on dev or a production cluster. So that kind of gives you an overview of how all the tooling fits together. Lastly, as we said earlier, this journey has just started for us, and we've kind of evolved this tooling over the past couple of months. But we're looking for, we're in pretty early stages, so we want to hear feedback. Basically, it's just we want to build out the value proposition and get some of that early user feedback. So over the coming weeks and months, we're going to focus on developer tooling again, building a plugin ecosystem to integrate with more languages like Python and Go. And these are just the foundations essentially. We want to then move on to building and integrating with data catalogs, and the plugin-based architecture will be key to that essentially. So with that, thank you very much. If you want to get involved, then please scan the QR code. We've got a GitHub issue tracker, so just give us a thumbs up on that, and then we can kind of take the boat from there. We really like to get feedback, right? So we want to select a couple of companies to run this with, to build out this product suite. So yeah, we'll be here for the rest of the day, so come find us. Any questions?